convergence is an idea that's an emerging idea in science and technology. And the notion is that we have conventional stovepipes, physics, chemistry, biology, sociology, but they typically work alone. And there are classes of problems that are appearing which increasingly require that they work together. And convergence is the idea of bringing together different disciplines to work in a cooperative and ideally seamless way on the same problem. It has the potential for increasing the power of individual fields by bringing cooperativity. To me, for convergence, the largest scale opportunities are in areas that start with a problem, and ideally a problem that society really cares about, which can't be solved by any one of the conventional disciplines alone, and in which we don't know what the underlying science is. And let me take an example. One of the problems the U.S. faces right now is reducing the cost of healthcare. We have a very interesting and in many ways effective healthcare system which is focused on treating disease at the end of life. So you have cancer and the medical establishment treats cancer. But one knows that ideally you'd prefer not to have it in the first place. You'd prefer to prevent it. Now, this idea of prevention as opposed to treatment is, of course, very familiar and falls under the general category of public health. What are the correlates with cancer? What are the exposures that might lead to it? What genetic dispositions are there that feed into a propensity to have cancer? But if you look at the areas that are involved in thinking about that problem, there's biology and related areas which thinks about the human. There's environmental science, which thinks about the environment that the human experiences. There's information technology to collect all the data. There's chemistry and physics to measure the environment and to provide the information that's required. There's mathematics to handle all of the statistical work that needs to be done. There's sociology to think about, once you know the answer, what do you suggest that people do? How do you get them to exercise more, or whatever the right answer might be? You put all of this together and you begin to get something that I'm very enthusiastic about, which is a high technology approach to what is now called public health. But it's going to require a very different set of players, a very different set of participants than the ones who go into high technology end-of-life treatment. So what we'll have to do is to build this new area with everyone cooperating to bring their skills to make it work. And if we succeed in this, with luck, it should be possible to avoid certain kinds of disease and, with luck, lower the cost of the healthcare system. Another really interesting example in urbanization is handling kinds of problems that we haven't even thought of as being really scientific problems. And one is the problem of so-called megacities. And megacities have no clear definition, but roughly they're cities with more than 20 million people in them. So an example is Mumbai, which is probably close to 50. Tokyo is in the same general size, and there'll be quite a number. And the claim is that in 10 or 20 years, maybe 10% of the world's population will exist in these kinds of cities. We have no idea how to manage that kind of collection of people. It's an enormously interesting problem in how do you get mass, that is just weight of food and water and clothes and goods in and waste out? How do you manage the distribution of power? How do you think about the epidemiology and public health? How do you think about entertainment and education? And each of those words is a word that we're very familiar with. We know what education is. But how do you really do it efficiently and well when you're working with that many people? So again, it's going to be a problem of how you use communications, how you think about sociology, how you move materials around, how you think about the control and management and conservation of energy. All of this has to fit together into a kind of management that is megacity management, which we really haven't thought about. Now, on the one hand, this is a very practical problem because lots of people are going to be there and much of the sociology of the planet will probably evolve from that kind of city. But on the other hand, we don't have the basic science in place to describe systems of that complexity, to understand what we need to do and what we need not to do. So it's simultaneously a very important practical problem and a very, very interesting scientific and technological problem. There are two separate issues, I think, in thinking about how convergence could evolve as a discipline in science and engineering and an impact on society. The impact on society comes from the fact that many of the problems that have this characteristic that they're macroscopic problems evolves from the idea that people will care about them. People will care about megacities, people care about public health, people care about education and how it's done correctly. And whenever you're dealing with technologies which evolve into actions and policies that touch on people, you have to think about what the unforeseen consequences are in addition to, as opposed to the foreseen consequences. So you think about efficient city management. Well, efficient city management means that you may need to know where people are or what they're doing or something more about the patterns of their behavior. And there are obvious issues with privacy and things of that sort that come up. So I think that part of the issue will be simply that in focusing on problems that have real importance to society and to individuals, there will inevitably be cases where you need to protect the rights of individuals and be careful about what's happening with the society. From the point of view of the scientific disciplines, there's another interesting problem, which is that one of the strengths of science is to learn a small thing very, very well. And when you talk about these problems, you're sometimes talking about large things where there may be deep areas of science that are required, but also you have to put together things in ways in which it may be that the combination is the most interesting thing rather than a deep dive into a specific subject. So we want to make sure that we retain both the ability of the sciences to really understand their particular areas while putting them together in a horizontal way, in a way that's more effectively able to solve societal problems. One of the areas that we work in, and this is an example from our own research, is the development of very low-cost diagnostics for the developing world. If you look at healthcare in Africa, in India, in various parts of the world, it really is not in any way comparable to what we have in the United States. Now, there's an ethical issue there, which is how do we share the benefits of a highly developed society. There's a very practical reason also for being interested, because if you look at where, for example, terrorism develops, it develops in parts of the world which are not happy with the U.S. for one or another reason. Not always, but you find that places like Darfur are relatively comfortable places to develop mischievous ideas. So from our own point of view, developing ways of distributing the benefits of what we do is a good thing to do. To put together diagnostics that are appropriate for that kind of environment, you have to understand that those countries often have, to a first approximation, not only no money for health care, but they have no doctors, or doctors are very limited in supply. They have a very distributed population, one that's very hard to get to. I mean, finding people in big cities is almost as hard as finding them in the countryside. They have limited resources. There's no clean water and often no electricity, and actually not even a shared understanding of what disease is. So you and I know what disease is, but for someone who lives in a totally different culture, the concept of what a disease is may not have a lot to do with viruses and microbes. It may have to do with other things altogether. So we started on this, which is a problem in diagnosis, by thinking first about the cost and simplicity. And our approach was to actually do something which has worked out quite well, which is to ask, what is the least expensive technology that we could find that could possibly contribute to this problem? And what we picked was printing comic books. And the idea was that if you think about every country in the face of the earth has newspapers and comic books. They're made in actually very sophisticated technology with a very interesting material, which is called paper, by printing. And so what we've done is to adapt this technology to making diagnostic systems. So instead of printing stories, what we print is little paper chips that enable you to do diagnosis based on a drop of blood or a drop of urine. So the idea there is to use, in this case, material science for public health with an emphasis on cost. Now, I've said that this is for the developing world, but what's interesting is that although the activity that we have, which is funded by the Gates Foundation, is intended for not-for-profit use in the developing world, there's now enormous interest in this for-profit use in our world, and part of the advantage of it is, because it is in principle so inexpensive, it has the potential to contribute to lowering healthcare costs through diagnosis in studies of epidemiology and things of that sort in the US. And if you think about diagnostics as an area, it's interesting that the cost of diagnostics is a relatively small part of the overall healthcare cost. It's maybe 15%, but it influences probably 60% of the total expenditure, because how you're treated depends upon what you're diagnosed with. So the ability to take a broad approach based on physics, information technology, cell phones and telecommunications, biology for the analytical systems, put them together for a technology that is really intended for much less affluent parts of the world, may in fact produce a technology which we in the United States and Europe and Japan will find very useful for as a contribution toward one of our big problems, which is lowering the overall cost of healthcare.